tomorrow night I'm going to get on later. We'll decide on the time and I'll post it in the announcement tomorrow, okay? Because I'll have volleyball games today, tomorrow, and Thursday. So it's not going to be 3 to 4. It'll be different times. So just make sure y'all are reading the announcements. For 46, a wind is blowing from the northwest toward the southeast. So everybody look at this. We have a wind gust, I guess you can say, that's coming from the northwest toward the southeast. So does everybody agree that it's going this way? Is that how y'all drew it? Awesome. So then it says the vector has an eastward component, which means the east part right here, of 5 miles per hour. And a southward component of 15 miles per hour. So what did I just make on my vector diagram? A right triangle. Good, Mary. So the question is asking you, what direction is the wind blowing? Okay, so remember your direction is this angle right here. Is everybody okay with that much? This one shouldn't have been too bad. This one gets tricky because of the way the answer choices are worded. All right, so how can I find that angle if this is a right triangle? SOHCAHTOA, and what trig function can we use? Tangent. So did y'all do tangent of theta equals the opposite, which is 15, over the adjacent, which is 5? So just make sure you do opposite over adjacent. So the opposite side would be the 15. Adjacent would be the 5 because it's touching the angle. You got lucky. That won't always work out. Make sure with tangent we do opposite over adjacent. And then how do you move the tangent so we can just find the angle? Tan inverse. Good. So theta equals the tangent inverse. 15 divided by 5 is just 3. So when you guys typed in tan inverse of 3, we should have gotten 71.6 degrees. Is that what we got? Okay. So now we need to talk about this one because the answer choices are worded a little bit different than ones we've seen before. So I want to talk about what this means. If you see east of south, all that means is you start in the south and go 71.6 degrees to the east. It's just like those quadrant bearings that we did. But if it says east of south, that means you start in the south and move that many degrees to the east, okay? So let me talk to you about why it's not A, because everybody always kind of gets stumped on this. The angle we found is this green one right here. Do y'all agree? Okay, that green angle is in between, or I shouldn't say in between. It starts right there on the x-axis, which means it's starting in what direction? East, and it's moving 71.6 to the south. Does everybody see that? The answer choices all say south of east, or east of south, which is south 71.6 degrees east. So look at this. What this means, this answer choice right here, means you start in the south and go 71.6 this way. This isn't the angle that we just found, is it? So it can't be A. That's not 71.6 because this one is. So if we found east 71.6 degrees south, how do I find this pink angle right here? What could I do? Good, do 90 minus that, because look, everybody, this is a right angle, right? So it's really, it says the direction, find the direction, but then you have to read the answer choices. They're all talking about the angle beside the one in the triangle. So you have to do 90 minus 71.6, which will then give you what? Good, 18.4. So it's not A because that direction is opposite of what we actually found. Okay, who's confused? Because some of y'all's faces look confused. Or are we just bored already? People at home, is anybody confused? So remember, you guys have a notebook check on Friday. My virtual kids, you need to get your notebook video to me on Friday. I would wait till then because I'm going to be checking all the way to page 50. All right, I'm going to go ahead and flip if everybody's good.
Wasn't this on the Delta Math yesterday?
Yes, good, Grace. So that's what I was about to ask y'all. And geometric, I did put 4 problems on that Delta Math yesterday that just asked you like what was the pattern pretty much. So when we're dealing with sequences, and we'll write this down in a second, but a sequence is literally just a list of numbers that has a constant pattern. So yesterday on the Delta Math, what was an arithmetic pattern? Do y'all remember? Did it tell you? Did anybody hit the help button? Okay, good. They both use A, I think. I use A for both. Good. Does anybody remember arithmetic? It was a specific pattern, what it did each time. If you didn't watch the help video, then you probably don't know. It's okay. You're okay. So arithmetic, and we're going to take notes on it today. Arithmetic sequences add or subtract. They have a common difference. Okay. Geometric sequences multiply. So geometric, you could consider division, but whenever you write like the formula for the sequence, you're always going to be multiplying. So same thing as dividing would be multiplying by A. My Math 1 kids can answer that. What's the same as dividing when you multiply by A? Fraction. Good. So geometric, we always multiply. Just if it looks like it's dividing, you're multiplying by a fraction. Okay? All right, so I'm going to do arithmetic first. That's usually the easier one for you guys, and then we'll move to geometric. All right? Does that sound good? Or do y'all want me to like do them at the same time so we can compare them? It's really up to y'all. One at a time. Okay. All right, so just some vocab for you really quick. So a sequence is just a list of numbers. It's similar to a data set, but there's not X's and Y's. It's just a list of numbers that has a constant pattern. All right, I'm going to give you some notation. If you see A sub n, that n is a subscript, it's below the A sub n, that tells you you're trying to find the nth term in the list. So let me give y'all an example before you freak out because I said nth. If I asked you in a list what the 15th term would be, they would write it like this, A sub 15. That just means find the 15th term in the list. All right, so what would A sub 1 be? Good, first term. I'm not trying to trick you. This should be pretty easy. They learned this in standard math 4 and in standard AFM also. Like the exact same lesson. So A sub 1 is the first term in the list. And then if they say A sub n minus 1, how could we describe that? What do you think that's used to represent? All right, let me give you an example. If A sub n was the 15th term, what would A sub n minus 1 be? The 14th. So it's whatever came before the one you're looking for. Does that make sense? Okay. So it's just the term before the nth term. That's really the only vocab you're gonna need to know. Yes, ma'am. Depending on who you had for Math 1, yes. I teach it to my kids in Math 1. The notation, yep. You might have seen this in Math 1. They always put a couple of these on the Math 1 EOC. When I have really low kids in Math 1, I don't teach it because when I'm doing the review, I just teach them to plug in the answer choices and see what works. But with my high kids, I usually teach this in Math 1 also. All right, so an arithmetic sequence, I just told you, is a sequence with what kind of pattern? Oh no. Adding and subtracting. Thank you, Brody. I'm glad Brody's here to listen and answer my questions. Adding and subtracting. So an arithmetic sequence is just a sequence with a common difference. Which means it's either adding or subtracting. Only bad thing about today's notes, it'll be a lot of writing, but the math should not be difficult. The sequence with a common difference, D, which means we're either adding or subtracting. All right, so if it's okay with y'all, I'm just gonna start off with an example. Is that okay with everybody? Okay. All right, what does the dot, dot, dot at the end mean?
That it keeps going.
Good, it's gonna keep going. The pattern continues, basically. Okay, so we don't know where this is gonna stop, but what do we know? We're adding, there's a pattern, how much? 20. Does everybody agree it's adding 20 each time? Okay, so for this sequence, the common difference is positive 20 because we are adding 20. So if they give you a sequence, what you had in your Delta math yesterday, you should be able to look at it and figure out the pattern. So for an arithmetic sequence, the pattern is called a common difference because it's either adding or subtracting. All right, so what we're going to learn today from this sequence, you can write two different formulas or two different equations to represent it, okay? So the first equation, and we're going to keep using this example, the first equation is called a recursive formula. And the second one is called an explicit formula. All right, let's talk about the recursive formula. Do you guys know what the word recursive means? Do y'all know what cursive means? Some of you are like, I know of cursive handwriting. That's actually where this comes from. What does cursive handwriting do? What does each letter do? It connects and it continues, right? So cursive means it continues. Re means whatever came before it, right? So we're continuing whatever came before that term. Does that make sense? So if they asked you for like the 5th term in the sequence, what would it be? 92. And you guys found that by looking at what came before it, right? AKA recursive. Even if I asked you to find the 7th term, you'd probably just add 20, add 20, add 20, right? That's recursive. What if I said find the 102nd term? I would really pray you would not add 20 that many times. Does everybody agree? Okay, so a recursive formula is what we use when trying to find the next or near the next term. So like if I asked for the 5th, the 7th, even the 10th or 12th, you could just keep adding 20, right? That'd be pretty easy. An explicit equation or an explicit formula is what you would use if I said find the 102nd. Okay, because you're not going to sit there and add 20 102 times. Please do not. Jared did that on his exam last year. Love that boy, but I walked by his desk and I was like, what is he doing? He literally added it like, I think the question said find the 96th term. And he was literally just hitting plus 20 in his calculator. I was like, oh my God. All right, explicit formula. You're going to write an equation that represents this sequence and then plug in whatever term you want to find. Does that make sense? So we use this when we need to find a large term. All right, so y'all know I hate y'all memorizing stuff. So I teach this different from other teachers. I found that the way I teach it is a lot easier because I'm not going to give you anything to memorize. So I'm going to teach you these two using our example above whenever y'all are ready. All right, so let's use our sequence above if y'all are good. What did we do each time to each term? Add 20. So if I asked you to find the 5th term, you guys said it would be 92 because you took the one before it and added 20. So for a recursive formula, to find the term we want, A sub n, we're going to take the term that came before it and then add the difference. So for our example at the top, I'm going to take the term that came before it, A sub n minus 1, but what's my difference for this sequence? 20. So we're just going to add 20. This would be your recursive formula. This is literally all you have to write. If it says write a recursive formula, you would write that and you'd be done. So this would be useful if they said find the 6th term. Let me just show you. A sub 6 we could take a sub 5, that's what comes before 6, right? And you guys just told me 5 would be 92, and we could add 20, and that would give us a sub 6. Is everybody okay with a recursive formula and its notation? Okay. You're just taking whatever comes before it, add or subtract the difference. All right, explicit formula. We usually have to talk about this one a little bit more. What kinds of equations from Math 1 added or subtracted in a specific pattern? What kind of functions? Uh-oh.
Linear.
Good, linear. Good. Linear functions in Math 1 had a constant rise over run, which meant they were adding the same number every single time, right? So for an explicit formula for arithmetic sequences, we're just going to write a linear equation. So I'm going to use our same example up there. A sub n equals, what are we adding each time? 20. So that's our slope or our rate of change. So you're going to do 20 times n. And then what would the y-intercept be? Be careful.
Your A1.
Not A1. A y-intercept is where the x is 0. So what would a sub 0 be in this sequence?
-2.
How'd you get -8? Good. She worked backwards, subtracted 20 from 12. So a sub 0 in this sequence would be -8. This would be your explicit formula. You're just writing the linear equation that works for that sequence. So other teachers, Mr. Polk included, they show you a formula for this that they want you to memorize. You know I hate that. So we're not doing that. We're writing the linear equation. It's so much easier because I don't even remember the formula. It's got 4 different things in it. I'm not trying to do that. And I don't think y'all are either. If I had to guess. This is all we're doing today. Do you guys feel like you could do this with arithmetic sequences? Can I give you one to try? Yeah? Okay. So this is your first official example. I want you to write a recursive and explicit formula for the sequence. Then find, Ross, pick a number. 16. So you're going to write a recursive and explicit formula for this sequence I'm about to give you, and then you're going to find the 16th term, a sub 16. All right, so you guys, while you're finishing writing, try to write the recursive formula we could use and the explicit, and then find a sub 6. We can't do it on Friday. We got a test review to go over. You have your final test for me on Monday. All right. I think we should be about ready. Recursive. For some reason, my kids always get stumped on recursive. Y'all, that's the easy one. You ain't got to do nothing. The recursive formula, you write a sub n minus 1 because we're going to use what came before it. And then what am I doing each time? minus 3. That's your recursive formula. That's it. Take whatever came before it, subtract 3. There's your recursive formula. You don't do the what?
We don't put like 16.
No. I didn't say find the recursive formula for a sub 16. I just said write a recursive formula. That's it. Y'all overthinking it. Explicit formula, we're not going to use what came before it. We're going to write a general equation. So if we're subtracting 3 each time, does everybody agree that -3 is the slope? So -3n, what would the y-intercept be? Good, good. Y'all got 15 because you worked backwards and added 3, right? To find 0? Perfect. There's your explicit formula. That's it. Now, when I said find a sub 16, I want you to tell me what the 16th term would be. I don't care which one you use, but just a piece of advice. If you're trying to find a term bigger than 10, this one's going to be faster. Exactly, Ross. You just plug the 16 into the n. So a sub 16, we're just going to do -3 times 16 plus 15. That'll tell me what the 16th term is. So that would be -48 plus 15, which would be -33. That's it. That's all you're doing for arithmetic sequences. Do we feel like we can write a recursive formula or an explicit or both if it asks for both? And then could we use one of those to find a term? Okay. People at home, y'all feel like you can do this? Y'all got to answer me before I move on.
Yes.
All right. So I'm going to add on. This one shouldn't be too bad either. And then we'll do probably one more. Yeah, we'll do one more and then we'll move on to geometric. All right, example 2. I want you to use that a sub 1 is 2 and that the difference is 5. And what I want you to do with these things, I want you to first tell me the first 6 terms. Then I want you to tell me a recursive formula for this sequence. And then I want you to tell me an explicit one. A1 is what you start with. Good, Ross. So I see a lot of you starting, which is perfect. Ross said A1 is what you start with. So the first term would be 2. What would the second term be? 7. How'd you get that? Added 5 because the difference is a positive 5. So then the third term would be 12. The fourth term would be, good job, 17. And the fifth would be 22. And the sixth would be 27. So hopefully if they tell you a sub 1 is 2, the difference is 5, or if they give you an equation, you can plug in 1, 2, 3, 4, 5 and find the terms, right? Y'all are, yes? Because on the homework, I give you an equation and I ask you to find the first 6 terms. So you're going to plug in 1, 2, 3, 4, 5, 6 into the equation. All right, a recursive formula for this one. Tell me what we could write. A sub n. Good job, Ross. And Brody, I heard you too. Good job. A sub n minus 1 plus 5. How, so like up here we subtracted and up here we added?
No, like instead of writing the n, are we ever going to write the
No, I'm asking for a formula. So you don't know what number term it is. So you put a sub n. Only time you'll see a number here is if they're asking you for a specific term, like the 16th or the 12th or the 22nd. All right, and then an explicit formula, if you look at your sequence up here that you listed out, we can do a sub n equals, what's my slope? 5. So did you guys write 5n? And then what's the y-intercept? Good, -3, because you would go back 5 to find the 0 term. Very good. So then we're not going to do it. But then if I asked you for the 92nd term, can you guys tell me what we would do? Perfect. Put 92 in for the n. We feel like we could do that? Y'all are awesome. All right, last one, and then we'll move on to geometric, and we'll probably do 3 examples in that as well. So the term 98 is in what position in the following sequence? I think I got some of y'all already starting. So if you're already starting, what are you doing? Give me some ideas how we could find. So I'm asking you what position 98 is in. So I'm telling you a term in this sequence is 98. I want to know what term. Is it the 12th, the 10th, the 16th, the 23rd? What could we do to find out?
You could plug it into the explicit formula and solve for n.
She's so good. You should really be a teacher because you worded that perfectly. You could write an explicit formula, set it equal to 98, and find n, solve for n. That would tell you what position it's in, right? The other way to do it, which is the long way, I would not do it this way. And on my test, you're not going to be able to because I think I asked for the 103rd term, would be to make a list and just keep listening out till you get to 98. I think that's actually what Jared was doing on his exam. Exactly. So let's write the explicit formula first, and then we'll set it equal to 98. So what am I doing each time? Adding 4. So we know, good. So we know that's the slope. What's the y-intercept of this one?
-2.
-2. And so now if we want to find out what term 98 is, put 98 in for a sub n, and we can solve for n. So what would I do first? Add 2. So this would be 100 equals 4n. Divide by 4, what would n be? 25. So that means 98 is the 25th term in the sequence. That would be your answer, the 25th term. So y'all feel like you can do stuff with arithmetic sequences. Perfect. People at home, y'all feel okay with arithmetic?
Yeah.
Yeah. Was that Taryn? Taryn sounds so disinterested all the time. All right, I'm going to keep going. A geometric sequence. We talked about this at the beginning. Let's see who remembers. Has what kind of pattern? Multiplication pattern. Good. So this is a list of numbers with a common ratio, not a common difference, which means it has a multiplying pattern. All right, so let's start off with an example again, and then we'll talk about how we would write the recursive and explicit formulas for it. Let's do 1, 2. So if I give you this sequence, 1, 2, 4, 8, 16. If I'm going too fast, y'all please let me know. My Week B kids talked to me about how I talk too fast, right, Cody? Or was it Kevin I was talking? It was Kevin. Kevin had a speech last week and he said he kept going over time. I was like, you can talk faster because you're talking kind of slow. Talk faster. 1, 2, 4, 8, 16. What are we doing each time? Multiplying by 2. So this would be a geometric sequence. I think Delta Math calls it a compound sequence. Compound interest, do you guys remember doing that? It's because we multiply when we find compound interest. So that's called geometric because we're multiplying. So the common ratio or rate is just 2 because I'm multiplying by 2. So let's see how good y'all are. What could be a recursive formula for this? Okay, no, you're right. He said A sub n equals. I'm taking the term that came before it, and what am I doing to it? Multiplying by 2. So you'll probably see it written just like this. 2 times A sub n minus 1. That would be a recursive formula. Remember, recursive just means whatever came before it, use that, and then use the pattern. So the term that comes before it, A sub n minus 1, I'm just going to multiply by 2. So a general recursive formula, because I know somebody's going to want one so they can look back, for geometric would be A sub n equals the rate times A sub n minus 1. That's just your general recursive formula for a geometric sequence. All right, let's talk about an explicit formula for geometric sequences. Think back to Math 1, and you did it in Math 3, and we did it in this class. What kind of functions have a multiplying pattern? Think about when we did compound interest, what unit was that in? Exponential functions. Good, KJ. So for these, we're going to write an exponential function. All right? So explicit form, we're going to write an exponential function. It is going to be a little bit different, just a little bit, than your traditional exponential function. So let's review. An exponential function looks like what? Y equals what?
X or b to the x plus
What's in front of the b? We don't do plus c in pre-cal. That might have been Math 3.
a.
Ooh, my Math 1 kids could do this. A times b to the x. Y'all remember doing that all the way back in Unit 2? It's exponential because x is the exponent. Uh-oh, okay. Remember that a out front is your initial value. The b in parentheses is the rate you're multiplying by, and then you raise it to the x. So for our example, this is how it's a little different. To find a sub n, we're going to start with whatever the sequence starts with. So we're not working backwards this time. Did everybody hear me say that? No working backwards. What does this sequence start with? 1. So 1, what am I multiplying by? Times 2. And because we don't work backwards in the beginning, they raise it to n minus 1. I am going to leave it like this because every single answer choice you'll ever see with a geometric sequence is always raised to n minus 1, not n. So I don't want to teach y'all to work backwards at the beginning when this is how all your answers will be written, okay? So 1 times 2 to the n minus 1, that would be your explicit formula. All right, so let's talk about it. If I asked you to find the 23rd term, what would you do? Plug 23 in for n. So you would end up doing 23 minus 1, which is 22. Do 2 to the 22nd, and then multiply by 1. Do we feel like we can try one? Can I give you a sequence and you try to set up the 2 formulas? All right. All of you look so enthused to be here. Let's do. I want the recursive formula, the explicit formula, and then I want KJ, pick a number. Plus 20, 24. You gotta make it big. All right, so use that sequence, write me a recursive formula, an explicit formula, and then find the 24th term. All right, recursive form, what'd y'all get? Not everyone at once. So Ross said we're taking the term that comes before it and multiplying by a half. Is that what you guys got? Good. All right, explicit formula, what'd y'all write? A sub n equals what? Negative 24 times a half to the n minus 1. Perfect. So to find the 24th term, you guys put that in for n, right? Yes? So a sub 24, I don't know why I was about to rewrite it, it's right there, is going to equal negative 24 times 1/2. And when I do 24 minus 1, I just get 23. So you had to do a half to the 23rd power and then multiply it by negative 24, right? All right, let's see what we get. Because I'm hearing it's something crazy. 0.5 raised to the 23rd times negative 24. Okay, I'm getting this. Is that what y'all got? Negative 2.86 e to the negative 6?
No.
Is that really not what y'all got?
Yeah, I got 0.00000286110.
That's the same as this. Oh, brain blast. Can I borrow some of these pen? Actually, I don't even care. I'll mess up the calculator. Everybody look. Let me write it down. That'd be better. Negative 2.86, and I'm not going to copy the rest of the decimals, times 10 to the negative 6. That's what that e negative 6 means. If you're multiplying something by 10 to the negative 6, you should have learned this in middle school. This is called scientific notation. How would I move this decimal to put it as a standard digit? We're multiplying by 10 to the negative 6.
Move it 6 to the left.
6 to the left. Perfect. So everybody look. 1, 2, 3, 4, 5, 6. 0.0000286. Is that what you say, Kendall? Is that what y'all got? It's the same thing. So if you use Desmos, I believe, unless there's 6 or more digits out front, it'll go ahead and tell you the standard number. If you use a calculator, it gives you scientific notation. But I'm also getting 0.0000286, and it should be negative for the 24th term. Now, how else could you guys have written that? What's your rate?
1/2
Half, which is a
fraction.
Fraction. You could also change this to a fraction if you used a calculator. Math, enter. Oh, it's not going to do it. That's fine. Desmo should do it for you. I can show you how to change it to a fraction if you would like. Okay? Good job, Ross. That boy said, I'm getting my extra credit today. All right, last one. I feel like y'all are pretty okay with geometric, right? So let's do one where we have to work backwards like we did with arithmetic. Oh my gosh, I cannot talk. So I want you to find out from this sequence, 1, 3, 9, 27, 81, what position is the term 2,187 in? And we will be done. All right, Grace, what did you tell us we do last time for these? You told us what to do.
You plug it in and solve for n.
Plug it into what? What do we have to write first?
The explicit.
Good. Very good. So write the explicit form. Y'all are listening, right? I think some of them are already doing it. Write the explicit form. Set it equal to 2,187, and we're going to solve for n. So I want you to watch on this one because there's multiple ways you could do these. What would the explicit form for this one be? A sub n equals 1 times 3 to the n minus 1. Very good. Listen to me carefully. It's exponential. The variable is in the exponent. When we did exponential functions and we had to solve them, do you guys remember what we had to do?
Log.
Good. Take the log. Now, how many of you enjoyed doing that? Yeah, none of you. You all complained about it. You still don't quite understand how to take logs, which breaks my heart because I spent like 4 weeks on that unit. But that's okay. You can take the log. That's how some of you may choose to do it. Me, I would guess and check on this one. You got to divide the number out front first, but it's a 1. So when I divide by 1, is anything going to change? No. So I'm going to leave it as 2,187 equals 3 to the n minus 1. And then I'm going to start trying to see 3 to the what will equal 3 to the n minus 1, because 2,187 should be 3 to some power if I'm supposed to have them equal. Do you guys remember doing that in this class where we got the same base on both sides to find the exponent? Okay, so I want y'all to just watch. In my calculator, I'm guessing and checking. I'm going to start, I know 3 to the 4th is 81. Nope. Yes. 3 to the 4th is 81. So I'm going to start with 3 to the 5th. Is that 2,187? So I'm going to do 3 to the 6th. Is that 2,187? So I'm going to do 3 to the 7th. Is that 2,187? So I think the easiest way to do these would just be to guess and check, y'all. So 3 to the 7th is what equals 3 to the n minus 1. Now here's where y'all will mess up. What does that mean n will be? 8. Good, Pradnia. So this term is the 8th term. If you want to take logs, you can. If you need to see that, come to office hours. But I honestly think guessing and checking for these is the fastest.